Good morning, students. Today we discuss about the concept of ionization energy and excitation energy. Here these are the simple terms. These are two types of energy required by the electron within an atom. What do you mean by ionization energy? Let us see here. Here this is the structure of the atom is there. As you know very well, one of the general concept. All the electrons revolving around the nucleus, they are not easily leaving the orbit. What is the reason? Because here all the electrons, they are bounded to the nucleus by one of the poles. That force is called as electrostatic force of attraction. In between electrons as well as the nucleus, there is a electrostatic force of attraction is there. That's why, because of these electrostatic force of attraction, this nucleus not leaving the electron from the orbit. Wherever it is the position of the electron, while revolving, it is the position of the electron, or else it is the position of the electron, whatever it is the location of the electron in the orbit during revolution, but this nucleus always attracting the electron towards its center. That force of attraction existing in between center of nucleus and center of electron, that force is called as, that is electrostatic force of attraction. But just you can think yourself, here our intention is to remove the electron from ground state to infinity orbit. What do you mean by infinity orbit? It means, it is indicating means we need to take the electron away from the atom. Then what we can do here? Because here nucleus is there, this nucleus is not letting the electron to go. But in order to take the electron away from the atom, we need to supply some amount of energy to the electron. If you supply some amount of energy to the electron which is present in the ground state, this electron absorbing that energy and it is overcoming this force of attraction by the nucleus and it is coming out of the atom. That energy required by the electron to come out to take the transition from ground state to infinity state, that required energy by the electron is called as ionization energy. What do you mean by ionization energy, or how to define this one? It is the minimum amount of energy required by the electron to take the transition from ground state to infinity state. Indirectly, what is the meaning of this one? In order to remove the electron from the ground state to out of the atom, that required energy by the electron is called as ionization energy. How to define this one? It is the minimum energy. It is the minimum amount of energy. It is the minimum amount of energy required by an electron. Required by an electron to remove or to come out or to jump from or to take the transition from ground state to infinity orbit. It means that infinity orbit, in the sense we need to take the electron away from the atom. Then to come out away from the atom or to eject the electron from ground state to the out of the atom, what is the energy required by that electron? That energy is called as ionization energy. Called ionization energy. Ionization energy. As you know very well, for hydrogen atom, what is the example? For hydrogen atom, as you know very well, E1 is equal to that is minus 13.6 electron volt. In the ground state of a hydrogen atom, the energy of the ground state for the hydrogen atom is that is minus 13.6 electron volt. Here this much of energy if you given to the electron, then this electron is jumping from first orbit to infinity orbit. Let us consider this is the electron revolving around the nucleus. This is the first energy level of hydrogen atom. In this first orbit, the electron or the energy of this first orbit is that is for hydrogen atom that is minus 13.6 electron volt is there. The electron is revolving around the nucleus in the first orbit with the energy of minus 13.6 electron volt. But our intention is to remove the electron from ground state to infinity state. Then how much energy we have to supply to the electron? Here the magnitude is minus is there. If you supply the positive 13.6 electron volt energy to this electron, then this electron energy becomes 0. Then immediately electron is coming out of the getting atom. Here, if you supply or if the electron absorbs plus 13.6 electron volt energy from outside, then the electron is removing from an atom. It means removing from an atom in the sense the electron is taking the transition from ground state to infinity state. Then what is the amount of ionization energy we have supplied? That is plus 13.6 electron volt. This is ionization energy required by the electron which is present in the first orbit to come out from the atom. Then what is the amount of energy that is ionization energy required by the electron? That is 13.6 electron volt. And next similarly another word is there, that is another term, that is excitation energy. What do you mean by excitation energy? Let us consider this is also energy required by the electron to take the transition from ground state to next higher state. For example, it is the amount of energy required by the electron to come out from ground state to infinity state. That energy is called as the ionization energy. And what is the excitation energy? Excitation means in order to excite the electron. Excite the electron means, let us imagine the electron is present in the ground state. In order to send the electron from this ground state to next higher level, this required energy required by the electron to go to the next higher level, that energy is called as a excitation energy. Or just you can imagine the electron is present in the second orbit and its intention is to jump from second orbit to third orbit. In order to jump from second orbit to third orbit, whatever it is the energy required by an electron, that energy called as excitation energy. There is a difference. Ionization energy is not the same as excitation energy. It is ground state to infinity. The energy required by the electron is called as the ionization energy. Excitation energy means wherever the electron is present, from that orbit to next orbit, in order to jump that level, whatever the energy is required by that electron, that energy is called as excitation energy. This can be defined as it is minimum energy required by the electron, minimum energy required by an electron to take the transition from one energy state to next higher state. That energy is called as excitation energy. For example, if it is present in the second orbit, in order to go to the third orbit, whatever is the energy required by this electron is called as that is excitation energy. For example here, example, imagine for hydrogen atom, the electron is present in first orbit. Electron is present in first orbit. Then what is its energy? That is minus 13 point, that is E1 is equal to minus 13.6 electron volt. But our intention is to take the electron from first orbit to second orbit. Then what is the energy of the second orbit? The energy of second orbit is is, as you know very well, that is E2 is equal to, that is minus 3.40 electron volts. Electron is present in the first orbit, its energy is minus 13.6 electron volt, and if the electron is present in the second orbit, the energy of this state is minus 3.40 electron volt. But our intention is to take the electron from first orbit to second orbit. Then what is the energy required by the electron? How to calculate that one? Just you can take the difference of 2. What is the difference of 2? 13.6 minus of 3.40. The difference between these two magnitudes, that is 10.2 electron volt. That is E is equal to E1 minus E2, that is minus 13.6 minus of minus 3.40 minus plus minus 13.6 plus 3.40, then you are getting minus 10.2 electron volt. And this much of energy is required by the electron to take the transition from first orbit to second orbit. This 10.2 electron volt energy required by an electron, that energy is called as a excitation energy. And these are two important terms, just you can remember. And next concept, that is limitations of Bohr's atomic model. You studied already this one, Bohr's atomic model. Bohr's atomic model, that is also called as hydrogen atomic model, because he has taken the example as hydrogen atomic model. And here, what is the meaning of limitations? The limitations we are going to call it as the drawbacks. Getting? You studied already the postulates of the Bohr's atomic model. There are three important postulates are there. First one is the electrons are revolving around the nucleus in a certain stable orbits. Those orbits we are going to call it as a stationary orbits. That is the first postulate. And what is the second postulate? That is angular momentum of the electron can be calculated by using the formula, that is mvr is equal to nh by 2 pi. And third postulate, whenever the electron is jumping from a higher energy level to a lower energy level, then energy can be calculated by the difference of those two energy states. These are the three important postulates you already studied in the previous class. And here there is a concept limitations, or you can also call it as the drawbacks of Bohr's atomic model. And here what is the first drawback? That is this Bohr's atomic model only applicable to Bohr's atomic model only applicable to hydrogen atoms. Applicable to hydrogen atoms or hydrogen-like atoms. What are hydrogen-like atoms? If there are something atom is there, if that atom is having only one proton, then that atom is also called as a hydrogen atom. The atom which is having only one proton, that is called as hydrogen-like atom. Or there is one more word is there, hydrogenic atoms also we are using. Only this atomic model applicable to the hydrogen atoms or hydrogen-like atoms. And if you take the consideration for another atom, just you can take the aluminium as an atom, then what he explained, Bohr, what he explained, these postulates, those postulates are not applicable to the other atoms. That's why for some complicated atoms, and this atomic model is not applicable. He taken only example of hydrogen atom, and whatever he has given the explanation, that is only applicable to the hydrogen atom. That's why this is also one of the drawback. Bohr's atomic model only applicable to the hydrogen atoms and not applicable to the some complicated atoms. Complicated atoms in the sense, for example, sulfur is there. The sulfur is not having only one proton; it is having 16 protons. That's why what he explained regarding in hydrogen atom, that explanation is not applicable to the sulfur atom. That's why this model is only applicable to the hydrogen atoms and not applicable to the complex ions or atoms. And what is second one? This is the first drawback. And second one, Bohr's atomic model. Bohr's atomic model cannot explain about intensity of spectral lines. Intensity of spectral lines. Spectral lines. As you know very well, what do you mean by spectral lines? These are the lines present in the screen whenever you are observing the spectrum. Here the spectrum is there. In the spectrum, just it is imagine it as a screen. On the screen you are observing some lines, and these lines we are going to call it as a spectral lines. And the intensity of these lines, that is cannot explain by Bohr. For example, here atom is there. This is a nucleus. These are the orbits. Electrons are revolving around the nucleus. I am sending one electromagnetic radiation. This is passing through the atom. Whenever this radiation is passing through the atom, the electrons present in the orbit, these electrons are receiving the energy from this radiation. How much energy given by the radiation to the electrons? By using that one, we are going to produce a spectrum. In the spectrum or in the spectra, you are observing some spectral lines. And this Bohr atomic model, he cannot talk about the intensity of these spectral lines. That's why this is also one of the drawback here. This is second limitation of Bohr's atomic model. And this model cannot explain about the intensity of spectral lines. And what is third drawback? And this atomic model cannot explain about there is an important term, that is explain about Zeeman effect. And the Zeeman effect, you are hearing this word first time. The Zeeman is name of the physicist, or he is the scientist. He given one explanation, and that effect or that explanation given by this scientist, we are going to call it as Zeeman effect. Let us consider what you mean by Zeeman effect here. And the spectral lines can be split by using magnetical field lines. What he explained, by using the magnetical field lines, we can possible to split these spectral lines. For example, here 1, 2, 3, 4, 5. 5 spectral lines are there. These spectral lines can be further splitted by using a passing some the intensity of magnetical field, or if we use the magnetical field, by using this magnetical field, these lines can be split. It is possible. Let us consider here spectral lines are there. If you send some magnetical lines passing through the spectral lines, then these spectral lines are splitted 2 into 4. Then this is a splitting of spectral lines by using the magnetical field, and that can be explained by Zeeman effect. And therefore, this Zeeman effect cannot be explained by this hydrogen atomic model. He is a person, or he is a scientist. He explained about the splitting of spectral lines by using a magnetical field. If the magnetical field lines are passing through the spectral lines, those spectral lines are getting splitted. And this explanation are why the splitting of the spectral lines is happening by using the magnetical field lines. that cannot be explained by using Bohr's atomic model. This atomic model means Bohr's atomic model cannot explain about the splitting of spectral lines. Splitting of spectral lines. Spectral lines. Splitting of spectral lines. Spectral lines by using magnetical field lines. By using magnetical field lines. Magnetical field lines. By using magnetical field, this effect is also called as Zeeman effect. Because this one explained by the Zeeman, that's why the name after the scientist is called as Zeeman effect. This is the third drawback. And fourth one, this atomic model cannot explain about splitting of spectral lines, about splitting of spectral lines by using electrical field. Spectral lines by using electrical field. If you pass the electrical field lines through the spectral lines, there is also possibility of splitting of the spectral lines. That also cannot be explained by this Bohr atomic model. Splitting of spectral lines by using electrical field lines. Electrical field. And how come it is happening? By passing the electrical field, what is the reason behind this one? Why the spectral lines are splitting further? That can be explained by one of the scientists. His name is Stark. That's why we are going to call it as Stark effect. And these are the four important limitations. Only applicable to the hydrogen atom. First one, and cannot talk about the intensity of the spectral lines. This is the second drawback. And next, by using or by passing the magnetical field lines, it is possible to split the spectral lines. Then, how come it is happening? That also cannot be explained by Bohr atomic model. And that effect is called the Zeeman effect. Next, fourth one, if you pass the electrical field lines through the spectral lines, there is a possibility of splitting of the spectral lines. And how come it is happening? That also cannot be explained by this Bohr's atomic model. And how it is happening? How by passing the magnetical field, how the lines are splitting? That can be explained by Zeeman. He is the person. That's why it is the Zeeman effect, the name after the scientist. And here, what is happening? If you pass the electrical field lines through the spectral lines, what is the reason behind the splitting of the spectral lines? That is explained by one of the scientists who is none other than Stark effect. That's why this effect is called as a Stark effect. That is the name of the scientist. But he explained, but Bohr's atomic model cannot explain about that one. That's why this is also one of the drawback. And next one, we need to study next concept. Here the next concept is, that is de Broglie explanation of Bohr's second postulate. Here you already heard the name, that is de Broglie. He is a scientist and he explained about a certain kind of waves. They are associated with a moving material particles. Those waves are called as de Broglie waves. And you might have studied that concept in the chapter as dual nature of radiation and matter. Let us consider what you mean by de Broglie waves are also called as a matter waves. Here let us consider, here the electron is moving from one point to another point. Just you can take the imagination. Let it is a A point and it has a B point. The electron is moving from A point to B point with a certain velocity. That velocity is somewhat less is there, and you are viewing the path of the electron is a straight line. But actually that is not a straight line. Here whenever the electron is moving from one point to another point, it is moving with a path as some kind of variations. but these variations our eye cannot sensing. If you see the path of this electron by using the electron microscope, instead of straight line, instead of exact straight line, you are observing certain or some variations in the path of that electron. What are these variations? These variations are nothing but the electron, whenever it is moving from one point to another point, it is also moving in the path of some kind of the waves in this nature. Those waves associated with moving material particle. What is the moving material particle here? The electron is a material particle, because material means metal particle. The waves associated with that moving material particle, those waves are called as de Broglie waves. De Broglie waves are also called as matter waves. Actually, the name of these particle waves are called as matter waves, but they are calling de Broglie waves also because this is just the name after that scientist who explained about the matter waves. That's why his name is coming here. Whenever the particle is moving from one point to another point, that particle is also associated with certain kind of waves. Those waves are called as de Broglie waves or matter waves. Here, this is the nucleus situated exactly at the center, and this is the structure of the atom. Let us consider here electron is there. Whenever the electron is revolving around the nucleus, whenever the electron is taking the revolution around the nucleus, it is not exactly moving in circular path. In this circular path, if you observe very carefully by using some instrument, whenever the electron is moving in its orbit, it is having some variations. These variations, if you zoom out and see clearly these variations are nothing but waves. The electron is a particle. Whenever it is revolving in its particular orbit, it is also associated, means that electron is also moving or it is associating with some kind of the waves. Those waves are called as de Broglie waves. That's why the electron is moving in the form of waves. It is also having some wavelengths. These waves are called as de Broglie waves. Whenever the electron, just you can imagine, this is the initial point. From this point the electron is starting, and after one complete revolution, again the electron is coming at this point. Here, whenever the electron reaching the first point, it creates a standing waves. Here reflecting, again it creates a standing waves. And these waves are, whatever it is a progressive wave or standing wave, whatever it is the kind of the wave, but these waves are called as particle waves or matter waves or de Broglie waves. And here the concept is de Broglie explanation for Bohr's second postulate. As you know very well, what is the Bohr's second postulate for an hydrogen atom? That is, the Bohr explained about the angular momentum of an electron in nth stationary orbit. What is that one? Whenever the electron is revolving around the nucleus in a nth stationary orbit or generally in a stationary orbit, its angular momentum can be calculated by using one of the formula that is given by Neil Bohr. That is, the angular momentum of electron revolving around the nucleus in a stable orbit. Its angular momentum can be calculated by using the formula that is nh divided by 2 pi. Or you can write mvr is nothing but this is L is equal to mvr. L is equal to nh by 2 pi. This is the formula we are going to use it for the calculation of angular momentum of electron. This is the formula given by Bohr in his second postulate. Here n is principal quantum number. Just you can call it as a principal quantum number, or else it is number of orbit. If the electron is revolving in the first orbit, if you want to find out its angular momentum, the n value is equal to 1. Or if you want to find out the angular momentum of the electron which is revolving in the second orbit, then n value is equal to 2. Principal quantum number in the sense that is indicating orbit number. H is a Planck's constant and 2 pi it is a constant. By using these two quantities, you are going to calculate angular momentum of electron. But here de Broglie is also giving explanation about this second postulate. Means according to de Broglie, the second postulate that is given by the Bohr, that is correct, and he is giving the proof of that one. And what he is doing here, let us consider according to de Broglie, or according to Bohr's second postulate, the angular momentum of electron. The angular momentum of electron is given by angular momentum of an electron. Momentum of an electron is given by the formula as that is mvr is equal to nh divided by 2 pi, and here n is principal quantum number. Its value is an integer indicating 1, 2, 3 so on up to infinity. Principal quantum number, or you can call it as that is orbit number. Principal quantum number. H is Planck's constant. And here de Broglie giving the explanation. According to de Broglie, what he is explaining, according to de Broglie, whenever the electron is revolving around the nucleus, it creates the matter waves. Means whenever the electron is moving around the nucleus, it is not only exact creating its path as a circular one, it has some variations. The electron is a material particle. In its path, it is having a certain kind of waves. These waves are called as matter waves. And how to find out that one? The wavelength of these waves can be calculated by, according to de Broglie, the wavelength of these matter waves can be given by, as you know very well that formula, lambda is equal to h divided by p. And what he is taking the formula that is n lambda is equal to 2 pi Rn. What is n? According to de Broglie, here n is nothing but number of waves. This is one wave, this is second wave, this is third wave, fourth wave, so on up to infinity. Number of waves, that is wavelength of matter wave, and this is 2 pi Rn. If you multiply, number of waves into wavelength of one wave, the value is exactly equal to circumference of this orbit, that is 2 pi Rn. Rn is nothing but which orbit you are taking, the radius of that orbit. This is circumference of that orbit is equal to n into lambda, wavelength of one wave, and this is number of waves. Next, what he is doing, n as it is and lambda can be given by using this formula. We can find out the wavelength of one matter wave. Wavelength of one matter wave can be calculated by using this formula. This is given by de Broglie. Here lambda can be written as h divided by p. Lambda can be written as h divided by p. This is equal to 2 pi Rn. And next, what he is doing, this is nh as it is, n into h. P can be written as m into v. Momentum is equal to mass into velocity of the electron, that is 2 pi Rn. And next, you rearrange the term here, nh divided by take 2 pi here, this is 2 pi, and send mv right side, that is mv Rn. What is this one? Angular momentum. And this is the formula given by whom? This is Bohr's second postulate. M into V into Rn, that is M into V into R, this is equal to nh by 2 pi. This is exactly angular momentum of an electron around the nucleus. mvr is equal to nh by 2 pi. This is second postulate. Of Bohr. For which atom? For hydrogen atom. That's why who started this derivation? This is given by de Broglie. He is using the concept of matter waves. He started the calculation. De Broglie started the calculation. Finally, what he got? That is de Broglie Bohr's second postulate. That's why he have to give the confirmation that regarding the Bohr's second postulate. that what he explained about the angular momentum, that is right, and that's why this is the concept of de Broglie explanation for Bohr's second postulate. You know very well Bohr's second postulate, mvr is equal to nh by 2 pi, you know very well. De Broglie started by the concept of matter waves and he derived the equation. Finally he got the expression that is exactly matched with the Bohr's second postulate.